Last year, this is made up. I try to use real stuff as much as possible in stats, but sometimes I make stuff up. This one's totally made up. Last year, Pike offered an after-school SAT prep class that students could volunteer to take. 44 students took the course and then took the SAT. The average SAT score for this group was a 1220. The average SAT score for all students who did not take the prep class was 1050. Is the situation described an observational study or an experiment? Observational study, why? What'd you say?
There's no proof.
What would we be looking for? I like what you're saying. I'm not disagreeing with anything that you said. Influence in what way? There we go. There we go. Nobody is making these students either take or not take the class. That would be called a treatment. When you impose a condition on a group, that is a treatment. All right, so this is an observational study. None of the students are assigned or forced to take the class. For an observational study, there is no treatment. For an experiment, on the other hand, there is a treatment that is imposed. What do I mean by imposed? Placed upon, like forced to. I mean, obviously nobody is forced, but you are told what to do. You're not just given free choice in the matter. Identify the explanatory variable and the response variable. Super close. Super close. We just need to clean it up a little bit. You're not completely wrong. It's just not fully correct. Explanatory, taking the class. Whether or not they take the class. We have to look at both possible treatments here. So whether or not they take the class would be the explanatory. And you said the response would be what? Yes, the SAT score. The explanatory variable is also sometimes called a factor. The explanatory variable is sometimes called a factor. Can you conclude? Oh, sorry.
No, actually, I got a 1220 on SAT.
Nice.
That's why it's
That is kind of funny that they picked that score out and that was your score, right? Can you conclude that taking the prep course will cause a student's SAT score to increase? Not really. Why? What'd you say? We could talk about for this group. Is the is the prep class or not taking the prep class the thing that caused the change? We don't know. We don't know. Yeah, that's
correlation doesn't mean causation.
Correlation doesn't mean causation. There is a correlation here. We saw a correlation. The 44 students that took the course had an average score that was higher than the students that didn't take the course. But students who took the prep course might just be highly motivated, so they're just going to study more anyway. I mean, I don't know. I don't know if the class is the thing that made the difference or not. I would accept that, yeah. I would accept that. I would encourage you to still try to think of what else might be influencing them because of what we're getting ready to talk about next. All right, you guys okay if I go to the next screen? Okay. Identify as many other possible variables that you can that might explain why SAT scores are higher for those who took the prep class than for those who did not. And I already said motivation level in the previous question. Motivation level could be influencing their study habits, and the motivation level, because it's influencing their study habits, would have a positive correlation with their SAT score. What else could influence this?
Parent expectations.
Parent expectations. I love it. Parent expectations. Grades. So I want you to think about in this context specifically. In this context. What else could be a reason that these students overall did better? Correct. We don't know how many were in the second group. Ebony.
I don't know how you would work this, but like since it's basically an additional class, it depends on people, like if they have time to take it.
I love that. I love that one. Time after school would absolutely influence this. Not only, sorry, hold on just one second. I agree with that. When we're talking about this, the time after school would influence their decision in whether or not to take the class, because if they don't have time, they can't take the class. But it would also potentially influence their score, because if they don't have a lot of time after school, they're probably not studying on their own as much either. So this influences both the explanatory and the response variable. That's what we want to be looking for here. And I still want to take some ideas here, but what we're looking for is, we've got our explanatory variable, whether or not a prep course has been taken. We have the SAT score. We know these things are correlated. We don't know that one is causing the other. Maybe motivation is the cause for the higher SAT score. And motivation is also related to whether or not they took the prep class. Oh, yeah, I got it. Back and forth, back and forth. What else could influence this? I heard job. I'm going to kind of leave that in the time after school thing, because that plays into it, but yes. Here's a calculator. I think this one has, yeah, that one has ink, or not ink, lead.
You actually learn something?
Whether or not you actually learn something.
Teachers or educators?
Teachers or educators' influence. That might have something to do with it, yes. What'd you say? A learning disability. Yes, I'm running out of room to write stuff down, but I'm loving these ideas, and I would be writing them down if I had more room. I had a couple of thoughts ahead of time, too, that I wrote down. If somebody's not planning to go to college, do you think they're going to take an SAT prep class?
No.
Do you think they're going to care about what their score on the SAT is? No. So that might be an influencing factor here, whether or not they're college bound. How many AP or DC classes they're taking could be an influence on this. I could see it influencing both ways. If you're taking a lot of AP classes, you don't have a lot of extra time because you're doing all of the work for those classes. But on the other hand, you're also being exposed to questions that are a higher level and might be preparing you for that test outside of needing to take a prep class. So I can kind of see it coming both ways. But the point is, it's connected to both my explanatory and my response variable. All of these are connected to both whether or not somebody chooses to take the class and what their overall SAT score is. These are all called confounding variables. Confounding variables. I have seen, at this point, several AP exam questions from the test where they ask, what could be a potential confounding variable here? And one of the things you have to do, if you're going to offer something up as a potential confounding variable, you have to talk about how it's connected to the explanatory variable and how it's connected to the response variable. So how is it connected here? Or just establish that there is a connection there, that these two things are related, and that this has an influence over your response variable. Number 5, design an experiment that would allow us to determine if the SAT prep causes an increase in SAT scores. Would an experiment allow me to determine cause? Yes. Yes. So, as I'm trying to determine cause, let's pick out just our juniors. I'm just using an example to set up an experiment. We could say I'm going to take all the juniors. I'm going to number them 1 to n, because I don't know how many juniors there are. Use a random number generator to select 100 unique numbers. Choose the juniors corresponding to these numbers to be part of the experiment. So if I have a well-designed experiment, the first thing I need to do is to get the participants using random selection. Is that always possible? No. It's best practices, but it's not always possible. Could we do this kind of random selection for a medication trial? No, that could be really dangerous. You don't give people medication just because you want to test to see what happens. So ideally, we are able to select our sample, or the people that will be involved in the experiment, randomly. But it's not always possible. All right, so now that I have the people that are going to be involved in this experiment, what do I want to do with those people?
Oh, split them into 2.
Split them into 2 groups. What do I want those 2 groups to do? One take the class, one don't take the class. How do I decide who goes into which group? Random. So we have to describe that process just like we've described it with selecting the sample. We're going to number these chosen juniors 1 to 100. We're going to use a random number generator to select how many numbers? 50. Use the random number generator, thank you, to select 50 unique or 50 non-repeating numbers. Assign the juniors corresponding to those numbers to take the SAT prep class. And then really important, and I wrote this in orange so that it would stand out against the blue, you have to say what happens to the rest of the people. We can't just leave it up to the imagination that the other 50 people are obviously going to not take the class. You have to clearly and explicitly state that. These chosen juniors that we are numbering 1 to 100, these are often referred to as the experimental units. These are the experimental units. Not a trick question, but almost, so stop and think about this. How many treatments are being imposed?
Can not be a treatment?
Yes.
Not doing something?
Not doing something is an imposed treatment because they didn't get to choose that they didn't do it. They were assigned to not do it. So yes, we have 2 treatments. Taking the SAT prep class and not taking the SAT prep class. We have 2 treatments here. And my groups should be roughly equal. Yes. In this case, they came out to be exactly equal, but if you think about the example that we had on the homework that was talking about the stratified random sample from the 3 different states with Amazon, and we wanted a sample of 100, I'm not going to be able to get 3 equal groups and have it come out to be 100. But I could do 34, 33, and 33, and they would be roughly equal, and so that would be okay. All right? So we've picked out the juniors that are going to be involved. We randomly assigned them to one of 2 treatment groups. Now what? Are we done?
No, we have to do the groups, do the.
Yeah, we have to actually go through and do the experiment. So, I don't know, let's say the class is like a month long. A month later, we're going to have all of the 100 juniors take the SAT, and then we will compare the scores between these 2 groups. That comparison at the end is really important because we need to see, is there a significant difference between these 2 groups? If there is, then we can state that the class caused higher SAT scores. And if there's not a significant difference between the 2 groups, then we say that it didn't cause the higher scores. All right. You guys ready to flip this over? Kevin's still writing for a minute. I'll wait just another moment, and then we will flip the page and finish this up. All right. So we had 3 learning targets for today. Looking at this drawing here, this is a drawing that helps us understand a confounding variable. It might be that A causes B. Or there could be some third factor that is connected to both A and B that could actually be the underlying cause here. We have our explanatory variable, which also gets called a factor. So if I say how many factors are there, I'm asking for how many explanatory variables there are. Sometimes there's more than one when we're talking about experiments. Response variable is the ending here, and C is our confounding variable. It is related to the explanatory variable, and it influences the response variable. You will be asked on questions that say, like, name a possible confounding variable. You have to establish, you have to explain how it's related to the explanatory variable, and you have to explain how it influences the response variable. So if you're going to pick something out as a confounding variable, you have to talk about these connections. Observational study, no treatments are imposed. The participants choose. Yes. What? Oh, thank you. In an observational study, the participants choose, and in an experiment, the researcher chooses. Experimental units. This is the what or the who that the treatment is imposed on. In this case, we were talking about people, so our experimental units are those 100 juniors. Depending on what kind of experiment is being done, it might not be people involved, but it might be objects, and in that case, it'd be the object that's being experimented on, the object that is being exposed to the treatments. Treatments is what is done or not done to experimental units, and you have to name them both. You have to talk about what happens to every single group you make. So if one group is required to take the class, you have to clearly state that the other group is required to not take the class. Levels or combination of levels of the explanatory variables are our treatments. All right. Take about 5 minutes to do the 2 questions in the Check Your Understanding section. Take about 5 minutes to do those 2 questions, and then we will go over those at 12:35. Absolutely, I'll be right there.
Right.
Mhm.
Especially this module right now. Can some of the stuff, because I didn't write a lot, so can some of the stuff be simplified in terms of how much writing we're doing?
A little bit, but not much, honestly. A little bit, but not much. That's why I'm constantly letting you know about the abbreviations that you can use, but this is, at its core, statistics is math plus technical writing.
Yeah.
And so we have to be as precise as possible, which means using precise language. Yep. You're welcome. It is. This chapter is probably, I won't say that it's the most writing heavy, but it's close to it. It's close to it. Like there's some other chapters where we'll do a lot of writing, but there's more of a pattern to the way that we write. And so it is writing heavy, but it doesn't feel as heavy because you know exactly what to say. About 1 minute left. Number 1, observational study or experiment? Experiment. Why? Treatments were assigned. Yep. This is an experiment. A treatment, Ben's house or Jerry's house, is being randomly assigned for the employees. They don't get to pick whose house they're going to. They're told whose house to go to.
There'll still be confounding variables.
So, yes, there can be confounding variables in experiment. Typically, what you do to control for the confounding variables is make sure that they are equally, like people that are on either side of this confounding variable are equally spread between my two experimental groups. So,
Like whoever your phone plans with, they might have a stronger signal here than other places. Like
yes. So,
Like
for
everyone-
example, if let's say AT&T has a much stronger coverage than Sprint, right? If Sprint just tends to drop calls a lot, I'm just making stuff up right now. I would want to make sure that I have people from both AT&T and Sprint at both houses. That's how you would try to control for that. And the way we do that is through random assignment. You usually don't go around and ask them like, do you have AT&T or Sprint? Okay, you're gonna go to this group. Okay, you're gonna go here. There is a way to control for that if we really think there's a confounding variable that's gonna have a lot of influence. We will talk about that next week. But random assignment tends to make sure that it doesn't get rid of the confounding variables, but it makes sure that they're equally distributed between my two experimental groups. So that hopefully that's not the thing that's different about my two groups. The only thing that should be substantially different between the two groups are the treatments. Okay? That doesn't mean that that's true for individual people, but for the groups as a whole. Number 2, part A, observational study or experiment? Observational study, why? Observational study, no treatments are imposed. They weren't told what to do. Nobody that was involved in this was like, you got to get rid of all your books. That didn't happen, right? What's the explanatory variable here? Whether or not the family has books in their home, or the number of books in their home, depending on how you're recording this variable. If you're recording this as a categorical variable, it would be whether or not they have books in their home. If you're recording it as a quantitative variable, then it would be the number of books in the home. And so what would the response variable be?
academic success.
Academic success. Explain clearly why such a study cannot establish a cause and effect relationship. Suggest a variable that may be confounded with number of books that the family have in their home. So why can't we establish cause and effect? How do we know? You're not wrong. How do we know? There's too many other things that could cause it. So if we wanted to determine cause and effect, we would need to have an experiment. Yes. Can't make conclusions about cause and effect without an experiment. Anytime they ask you about cause and effect, you go looking to see if an experiment was done. If an experiment was not done, nope. Can't talk about cause and effect at all because it wasn't an experiment. Full stop. Done talking. Then it said, suggest a possible confounding variable. What I picked was studying. Maybe students with more books in their home tend to study more, and it's the extra studying that results in greater academic success. That's not the only possible right answer there. That's just the one that I picked for today. Yes?
Would like the size of their family count?
The size of their
I don't know
family.
how it affects like academic success, but I can see how it affects number of books. Because I have 7 people in my family, so we have a lot of books.
So you have a lot of books.
But like a family with like one child and just like a mom and dad and a child, like they probably have less. There's a chance that they have less books than we do because there's less of them.
Because there's less of them. So when you're talking about confounding variables, you do have to be able to relate it to both the explanatory and the response variable. So number of people in the family is definitely related to number of books in the house, but if we can't also make a connection with academic success, then we can't call that a confounding variable. You guys are asking fantastic questions. Absolutely fantastic questions. Homework is due on Wednesday. You can start on it, but we haven't really dug too deep into this yet. But we have talked about the beginnings of how to set up an experiment, so you are welcome to get started on the homework.